Hello, welcome to Attributes of Absolute Value Functions. So today we're going to learn about all the things that go along with an absolute value function. So first, you need to know that a parent function is the most basic function in a family. What that means is that you can have a really simple function like y equals x. That's a parent function. Y equals the absolute value of x. That's a parent function. Y equals x squared, a quadratic, that's the parent function, because then you could add stuff. So you could say plus 2 to all of these, and that's not the parent function because you've now added 2 to it. So that's all that means. Now an absolute value function is where f of x equals the absolute value of x. So those bars are called absolute values. Don't say bars, say the absolute value of x. That's how you pronounce it. And the absolute value of a number is its distance from 0. So, in other words, distance is always positive. So you're always talking about the positive version of a number, but whether that's positive or negative. So the positive version of negative 2 for this table is 2. The positive version of negative 1 is 1. The positive version of 0, well, 0 is 0, doesn't have a sign. The positive version of 1 is 1, and the positive version of positive 2 is still positive 2. So if you were to graph this, you would go to negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. So all of your absolute value functions make a v of some kind. Now this is the parent function. Starts at the origin and goes out from there. Perfectly the same on both sides. Now, whenever you deal with an absolute value function, you're going to have to find the following things: domain and range, the intercepts, symmetries, and the max and the min. Now, we talked about domain and range in our last lesson. Intercepts. Intercepts are where it crosses either the x or the y, so you have to include all of them. If it crosses the x-intercept twice, you write both. If it crosses the y-axis 3 times, you write 3. Not that that'll happen as often. Actually, when you're dealing with functions, it won't, but that doesn't make it any less important. Symmetries is where it cuts the graph perfectly in half. So if you can fold the graph in half and have both sides be exactly the same, you have a line of symmetry, because that's where it causes the graph to be cut in half perfectly. Then we have the last but not least, maximums and minimums. Now maximum. When you think maximum, you should think big, because you're talking about max. So that's when we're talking about the highest point on a graph. And it only has a max if it stops. If it goes on forever and ever, that doesn't count as a max, because infinity is not a number, right? You can't pinpoint the number infinity. Same thing with a minimum. If it goes on to forever down, it does not have a minimum, because it keeps going. It never stops. So a minimum is its lowest point, because you're thinking min. Min is little. Min is as far down as you can possibly go. So whenever you do that, you're always talking about the y value. Not the point, just the y value that goes right there. So let's do these. Let's do this for a couple of absolute value functions. So, domain. You know, domain is left to right. Well, this goes left to infinity, right to infinity. We've got negative infinity to positive infinity, or you could always say all real numbers. Now, range. Range is bottom to top. Does this go down to negative infinity? It does not. It starts right here. But remember, when you're talking about r, you're talking about the y value. So it doesn't go anywhere off the x-axis, which means we're starting at 0. Okay, not 1, 0. And is that included? Is there an open circle there? So it gets a bracket, and we're going up forever and ever, which means it's going to infinity. Now, if you were going to write that as an inequality, you would say that y is greater than or equal to 0, because y is, in fact, always, always, always greater than or equal to 0. Now your x-intercepts. Where does it cross the x-axis? Where does it touch the x-axis? Well, right there. Touch the x-axis, right there. And that is the point 1, 0. Doesn't touch anywhere else, so we only have to include that one. The y-axis is over there. Well, that's a point. Again, it's only touching once or crossing once, and that's the point 0, 1. Now for symmetry, we want to be able to cut this thing in half. And that cutting in half, that's going to be right here. Okay, well that is a line. Ladies and gentlemen, what I just drew is a line. That is the line x equals 1. Okay, now it is a what? It is a line, which means you must write x equals 1 because that is the equation of a line. If you exclude the x equals, you are getting it wrong. It's x equals 1. I promise you I will mark it wrong if you do not put x equals. Now, why is it x equals and not y equals? Well, y is always changing on that line. So here, y is 1. Here, y is 2. Here, y is 3. Here, y is 4. But x is always the same. So the reason it's x equals 1 is because x equals 1 no matter where you are on that line. Okay? Now finally, the max-min. You can only have one or the other. So, does this have a top point or a bottom point? This has a bottom point. Okay? It comes to a point at the bottom, not at the top. And I'm going to show you an example of what that looks like. But for now, just know that this is going to be at the bottom because it goes up to infinity. It never stops at the top. It only stops below. So you can mark out the max. That's not a thing. And the number is the y value, not the x value. So the y value here is 0, which means our min is 0. Now that is a number because I just want the y value. Let's do that one more time. We'll try not to take forever. Domain, again, left to right. It goes left forever and right forever. Even though it's going down and to the left, it's still going left, right? That will eventually span out as forever. It never actually stops. Same thing here. So we're going from negative infinity to positive infinity again, or you could say all real numbers. Our range. Remember, we go from what to what for range? We go from bottom to top, which means that if you're starting at the bottom, does it ever stop going to the bottom? No. So we actually go from negative infinity to the top. Now our top this time stops right there. So it goes until you get to 2. And that 2 is in fact included. So you could also write that in the same way I wrote the other one, as y less than or equal to 2. And the reason it's less than or equal to 2 instead of greater than is because everything's below 2. If it were greater than, you'd be making the v go up. But instead it's like a pyramid. It's going to go down. X-intercepts, we actually have 2 of them. They're here and here. If you were to graph that and try to find it, you would be a little bit more accurate. Trust me when I say it's negative 2/3, 0, and positive 2/3, 0. Or you can go look it up on a graph. The y-intercepts, where does it touch the y-axis? Well, it actually touches at the very top, which is the point 0, 2. By the way, the top and the bottom, max and min, also called vertex for these. Okay? So this happens to be the vertex. It is the topmost point. It's the peak. Okay? Then, line of symmetry. What do we have to do to cut this exactly in half? Well, if you look, it's kind of already done that for us. It's right here. Now again, that is a line. That is a line. And it's vertical, so it's x equals, what does x equal right there? It equals 0 because it's on the y-axis. So x equals 0 is our line of symmetry. If you just write 0, you get it wrong. Finally, we need to find max min. Well, does this have a top or a bottom? This is an example that has a top. Notice it's pointing, it's opening down, so it has to have a top point. If it were opening up, like on example 1, it would be a minimum, a bottom point. But that is it, and that was the answer for, we're finding the max. So let's take out min, that's not an option. And again, we're only looking at the y value, the number. So if we go to the y value, that's 2, so the answer is 2. Have a wonderful day.